All right, so the other special right triangle that we're going to talk about is the 30, 60, 90 triangle, which is just basically half of an equilateral triangle. All right, so again, we can just, if you take half of, of an equilateral triangle, you divide it down the middle from vertex to the opposite side, you get the 30, 60, 90 triangle. Now, for the standard 30, 60, 90 triangle, I'm going to call the length of the hypotenuse 2, which if you imagine that we had originally a, a equilateral triangle, then all of the side lengths were 2, and if we split it in half, then we get half this, or this, of this other side, this opposite side. And so the length of this side, the short side, is 1, right? Because it's half of the length of uh, the the side of the equilateral triangle, okay, which becomes the hypotenuse. And then we can find the third side. We can find the third side with a Pythagorean theorem, right? So I'm just going to take a squared plus b squared equals c squared, but this time I know c squared. So if I take c squared minus b squared, all right, if we call this b, then this other side has to be, b squared has to be, or a squared, sorry, a squared has to be 3, so this side here is the square root of 3. So that's the standard ratio, 1, 2, square root 3. But remember, the longest side is the hypotenuse, and 2 is greater than square root 3, so 2 is the hypotenuse, okay? I always think of it as 1, 2, square root 3. That's the standard ratio for a 30, 60, 90 triangle, but just keep in mind that 2 is the hypotenuse. All right. So, and then we're just, any 30, 60, 90 triangle is just basically a scale model of this standard 30, 60, 90 triangle. Okay. So we just need to find the scale factor, and then we can just scale it up or down to find the other sides. All right. So I worked through this example 3. You can read through how I did it. But what I want you to do is, again, think of it in terms of the scale factor. All right. So, what we want to do to find the scale factor is just take the ratio of the length of the side that we know, which is 1, over the length in the standard 30, 60, 90 triangle, which is 2, right? It's the hypotenuse that we know here. So the corresponding side is in the standard triangle is 2. So basically this triangle in example 4 is just a scale model, but everything's scaled down by a factor. It's scaled by a factor of 1/2, right? All the side lengths are just going to be half of what they are in this standard triangle up here, where the side lengths are 1, 2, square root 3. So we're just going to take each of the sides and multiply by 1/2. All right. So for side A down here, the corresponding side in the standard triangle has a length of 1, right? And then we're just going to multiply it by 1/2. So in this triangle, in example 4, A has to be 1/2 of a unit long. And B, now in the triangle, the standard triangle, it's square root 3, but then we're scaling it down by 1/2. So we're going to get square root 3 times 1/2. So this side, B, is square root 3, square root 3, that's right, 3, square root 3 over 2 units long. Okay, that's all there is to it. So you should be able to go ahead and work through these discussion questions. Now, we're not actually going to do these in class. They say discussion questions, but I want you to do these on your own and submit them on Monday. Okay, so I will let you go ahead and do that, and we'll see you in class.